All right, so please don't get mad at me as we go through this, but we're going to learn an explicit formula which will kind of take place of what we did in recursion. But recursion is important because it helps you develop some thinking for when you get into series when it comes to your calculus time. So let's get into explicit now. I think you'll like this better. So that gives a direct relationship between two quantities. And probably the most common explicit formula, or some of the most common, are like your slope-intercept form, y equals mx plus b, things like that. Okay, like your quadratics, stuff like that. So those are explicit, right? Your u sub n, that's using recursion, so that's not explicit. So now we're kind of getting away from that. So we're going to take our recursion and turn it into an explicit formula now. In our explicit formula, we're still going to use u sub n for right here, but we're going to write it in terms of n now. So we're just going to have an n, and I'll talk about why we need that. So first off, I have a sequence that's beginning at 45 here. So I got 45, and it's adding 18 each time. So I'm going to just write my next couple terms, 63, 81, 99, okay, and it keeps going all the way to the nth, or what we should say, the u sub n, right, value. And then we have our terms. So 45 was our 0th term, 63 was our first term, 81 was our second term, right? And I knew 45 was the 0th term because of that u sub 0 right away. 99 was our third term, and we're going all the way to the nth term. Okay, so I want to be able to plug in an n into this equation somehow, so I can just put in a number for n. If I say I want the 70th term, I can plug in 70 and solve. So let's think about that. Well, if I were to plug this 45 into this equation below, this formula, where would it go into? Yeah, it goes into there, right? I plug in the u sub 0 term to find the first term, and I would just add 18 to it. So I know that it starts with 45, and then I also know that we're adding 18 to it. But here's the trick. Do I just add 18 one time? Well, let's think. If I wanted the first term, the next term after 45, I'd add 18, right? But if I wanted the second term, I'd add another 18, so 36. If I wanted the third term, I'd add another 18, so 54. So what's really happening each time? I'm taking, this first one was 18 times 1, this next one was 18 times 2, this next one was 18 times 3. And if you notice, these guys right here match up with the spots right here. So 1 is really, 45 plus 18. And 2 is really 45 plus 36, right? So on and so forth. So instead of writing 1, 2, and 3, we're going to write n there. So 18 times n. So now I could use that equation. Let me test it. What would be the fourth term if I did another 18? That'd be what, 117? So if I plug in 4 for n, let's try that. So I'm going to find u sub 4, right, the fourth term. 45 plus 18 times 4, and that would give me, 18 times 4 is 72, and 72 plus 45 is 117. So yeah, it worked out. The fourth term is 117. So it's kind of nice. So basically, I just plug in my initial term in for the u sub n minus 1, and I just add an n to what's ever being added or subtracted. And that's only as long as it's an arithmetic sequence, right? As long as it's just adding or subtracting. It works nice and easy like that. And that's all we're going to look at today. So let's do one more here. So recursion. Remember, so u sub n equals, so I'm going to plug in the 3 in for that u sub n minus 1. And then what do we do to the 2? Oh yeah, add an n to it. So plus 2n. And if you'd like, you can flip these two guys around. It doesn't matter. Why might some people do that? Well, because when we get using linear equations, a lot of people like slope-intercept form, and that's y equals mx plus b. So it's kind of nice. Well, yeah, let's think about that too. It's going up by 2 each time, right? Isn't that your rate? Well, and the rate is the same thing as slope. And if you notice, slope, right there, m, that's what it is in front of the x. So now we just have n's instead of x's, right? And a u sub n instead of a y. It's really the same thing. And we'll look at that in a second. But now I have an equation to help me solve some things. So what would be u sub 22? Well, I just use my guy right here. So 3 plus 2 times, well, 22. So 44 plus 3, so u sub 22 equals 47. There we go. What about this? What if it says u sub n equals 291? Well, where would that plug into if I wanted to use my explicit formula? Now it plugs in right up here, and we're solving for n this time. So 291 equals 3 plus 2n. And then we could subtract our 3, and we got 288 equals 2n. Divide by 2, and what does n give us over here? 144. So the 144th term is 291. All right, so we're actually solving for n in that case. All right, so a little more practice. Let's do one with a negative now. Does anything really change? No. This goes in for my initial. Guess what? Put an n after there. So we got u sub n equals 5 minus 3n. And you could test it if you wanted to, right? Because 5 and then 2 and then negative 1. But we don't need to. I got this down. Let's do another one. Let's see if this gets tougher. Negative 4. All right, put that in my first term. Throw an n right there. Done. All right, so u sub n equals negative 4 plus 5n. Should work out, right? Because I'm starting at negative 4 and I'm adding 5 each time. Moving on. All right, so basically that's only for arithmetic sequences, right? When you're just adding or subtracting. So let's take a look at the difference. Recursion. Starting value is u sub 0. Explicit, our starting value is technically our y-intercept, okay? And you'll see that in a second, why that is. Value added or subtracted each time. That was the slope, right? Because if you take a look, we had our initial term, and then we added or subtracted something, and all we did was, if it was like 2, we just added an n to it. Remember, that's the slope. That's the number that's in front of the x. So that's kind of the slope there. So here we go. So if you think about our initial term is the y-intercept every single time, because that's kind of the starting point, right? That's our y-intercept in slope-intercept form. And then the number that's being added or subtracted is the slope, right? The number that's in front of the x. So that's why I always throw an n after it, because it's really like the x for slope-intercept form. And what your book is going to use is this form right here. This is called just intercept form. And I don't care what you use. This just gets confusing because now they represent A as the y-intercept, and they represent B as the slope. And that just kind of confuses me. All they're really doing is just flip-flopping the two terms. They just flip-flop these two guys around and give them different variables. That's all they did. So you can use either form. I just prefer y equals mx plus b because that's what I'm used to. So when we do recursion, remember it makes a discrete graph. It gives us points, right? Points. They're not connected. With explicit, now it's continuous. Now we get lines. And with arithmetic, they're all going to be linear. All right, so let's apply this with an actual situation. So it says a gardener planted a new variety of ornamental grass and kept a record of its height over the first 2 weeks of growth. So first thing, how much does the grass grow each day? Well, let's see. Days. I got 3 days, then I got 4 days, then I got 3 days, then I got 4 days. So let's kind of calculate what it grows each day. So it doesn't matter which range I grab from, but let's just say I use these first two. So from 4.2 to 6.3, how much did it grow? It grew 6.3 minus 4.2, which equals 2.1. So did it grow 2.1 centimeters? No, that's in what? How many days? From 0 to 3. So I better subtract as well. 3 minus 0, which is 3. So I have to divide 2.1 divided by 3. So that gives me 0.7, I should say centimeters. Well, it kind of tells me up here. I got centimeters up top over days on bottom. So it's like centimeters per day. Centimeters per day. I'm going to write that as an actual nice little label there. Centimeters per day. Okay, so use that table. Just be careful. If it's not counting by ones, you're probably going to have to subtract and then divide just like we did. All right, so now let's use that. Write an explicit formula that gives the height of the grass after n days. So n is representing days. I'm going to use h to represent height. Okay, I'm going to use h to represent height. So I want to find the height after n days. Well, what do we do with the n? Remember, the n applies to our rate or our slope. So this guy right here. So that's where I can say my 0.7n, right? Because it's going up by 0.7 each time. And then we always have our initial height that's being added or subtracted. And do I know the initial here? Yeah, 4.2. So I put on plus 4.2. Because then if I think about it, if I plug in 0, write down it for n, I get 4.2, which is good. If I plug in 3 for n, I get that times 0.7, then plus 4.2, I get 6.3. So that works out, right? I just kind of flip-flop the order. Really, this is like u sub n equals 4.2 plus 0.7n. But now I just replace u sub n with h for height, and I flip-flop these two guys around because I like having it in slope-intercept form. That's just kind of fun for me. Then it says, how long will it take the grass to be 28 centimeters tall? Well, now you have a nice equation. Well, where do centimeters go? That's height, so that goes here. So I got 28 equals 0.7n plus 4.2, and now we're solving. So subtract that 4.2 over. That's gone, and so then we're at 23.8 equals 0.7n, and divide by 0.7, divide by 0.7. And so how many days would that be? 34 days. And make sure to always have a label with the story problem. Donezo. All right, cool beans, right? So just make sure, now with the explicit, since we're only dealing with arithmetic right now, everything's going to be kind of linear, so that slope-intercept form works. But we're just basing it off of what we did in recursion and now making it explicit, kind of tying the two together.